Next one, we're going to talk about the critical values. The critical values is used as part of the process to find the local max, local min values of the function. By definition, the local max, local min, let f be a function defined at x equals c. Define means you can find the function value at x equals c. F at c, or the function value at c, is called a local maximum or a relative maximum if there exists some interval AB that contains C such that our function value is less than or equal to the function value at C on the interval AB. And then the second part, the f of C, which is the function value at C, is called a local minimum or the relative minimum if there exists some intervals, the open interval AB that contain the C such that all function value is greater than or equal to the function value at C, or f of C is the lowest value within that interval. So we also say that a local extreme value or the extremum occurs at the point C. Recall C is the x and the y is the function at C, or that the point CFC is a local extremum with the understanding that the y value FC is actually the local extremum. The local means a relative, so just within the closed interval that you are working on. Extremum covers both like the maximum, the minimum. The theorem of the local extrema, if a function f is continuous, continuous means the graph is smooth for the interval AB, and C is located within point A, point B, or between A and B. The function at the point C is either a local maximum or a local minimum. Then gonna be two cases. First case, the derivative at the point C equals 0, or the derivative at the point C doesn't exist. The case that the derivative at the point C is 0 is the case of the horizontal tangent. And the second case, in the case of the vertical tangent, recall the slope of the tangent line is a derivative. So basically, when you see the graph turn, you have the horizontal tangent, the derivative gonna be 0. And for the vertical tangent, in the case that the graph change suddenly, something like that, you have the corner or the cusp that's going on, or the peak within the graph. So at that peak point is the derivative doesn't occur. In that case, we still consider that the local max or the local mean occurs at that point. Now, what does it mean by the critical values? The critical value of the x are those value C in the domain where the f prime is 0 or the f prime doesn't exist. So you're gonna find the derivative of the function and then consider two cases. The case at the f prime 0 and another case the f prime doesn't exist, and find the value C that satisfy both cases. The value C is called the critical value. From the figures that you see, the first one, the graph is smooth and the continuous. You see the lowest point here. This one is called the local minimum occurs at x equals c, and you see the horizontal tangent. Similar to the second diagram, you have the graph that increasing and then decreasing. The slope at the point C is 0, or you have the horizontal tangent. For this case or case B, the function at C is called the local maximum value of the graph. And the case on the right, or the right part of the graph here, you have the graph as a smooth graph, but it has the quick turn. And that quick turn, the derivative is undefined, but we still see the local maximum occurs at the order pair C, f of C. And I'm going to put a note here. These two, the derivative at the c equals 0. The last one, the derivative at c is undefined or doesn't exist. And then the next set of the diagram, you see that the graph is decreasing. And then at the point C, you have the horizontal tangent. And similar to the second one, at the point C, you have the horizontal tangent. But in this case, even though you can find the derivative, but the graph doesn't show that the point C or x equals C will give you the local maximum or the local minimum. So in this case, the local minimum and local maximum doesn't occur even though the derivative is 0. And the last case, you have the graph that are falling down, and at the point x equals c, the derivative is undefined, but still you don't see the sharp turn or anything. It's just the graph like goes smoothly, but it happens to have that the derivative is 0. So for the case, the last three graphs here, there are no local max, local min, because the sign of the derivative doesn't change from one side to another side on the left and on the right side of the derivative to be 0. Because as the first graph here, the derivative is negative side and then 0, and then back to the negative side again. So the sign doesn't change. And for the second graph here, the graph is rising, so the derivative is positive, hit the point that the tangent is horizontal, and then back to positive again. The last one is the case at the negative slope to undefined or the doesn't exist graph or the tangent, and then back to negative sign again. As you see at the critical point here, the sign doesn't change from one to another. Therefore, the three cases here, there are no local max, local min. The first derivative test is a test to find the local max, local min. So how do we find that? First of all, we're going to find the critical value. We're going to find the derivative, solve for c when f prime is 0 or the f prime is undefined. And then we're going to draw an analysis line or the real number line to verify the plus minus sign of the f prime. Okay, in this step, many textbooks, they use the term the sign test. Okay, the sign test by checking plus minus sign and also 0 of the derivative. And for this one, we're going to look at the interval that the sign switch from one to another. So from the sign change from positive to negative, then the function at the point C, we call the point C is the critical value. If the sign change from positive to negative, that means the sign change from increasing to decreasing. That point gonna give you the local maximum. Another way, if the graph is falling and change to rising, that point C is the local minimum. And the last part here, if there is no side change from the left to the right of the point x equals c, so then the function has no local maximum minimum. The extremum cover both max and min. So we have to look for the point that the sign change from positive to negative or negative to positive. So this is about the first derivative test for the local extrema.